Tries to overcome this whole shit.
You're the one doing it.
There's no one has ever tried
Alright, if you were confused, you might want to write some of this down. Confidence intervals, we're going to go over it very, very quickly. Everybody's actually acting like they're focused and paying attention. We won't go on to something new. I'll just
something new. It's old.
I'm going to have a headache, which I already had, and we will go on. All right, with confidence intervals. And most of the confidence intervals we're going to start with is for confidence intervals. We're going to do large samples and small samples. We'll do small samples next week, large samples. And what they consider a large sample is the same thing as we did last chapter. Anything bigger than 30 is considered a large sample. So all a confidence interval is, and I'm going to try to sort of explain an overview here so you'll understand it. If we have a sample, our sample, whatever the numbers are, and we find the mean of that sample, all we're going to do for a confidence interval is we're going to put that mean right in the middle. Say we took the IQ of all you guys and we averaged them all up. All right, that'd be a small sample because there's only 10 of you or whatever. But if there was 30 of you, we put that right in the middle, and we know that the mean IQ in here is probably about 130, right? That's probably about the mean IQ in here.
I don't even know what that is. Kind of like.
Isn't that like super high?
That's pretty high.
Yeah.
So I was trying to be nice for
Yeah.
once. So if that's the mean IQ, when we're talking about confidence intervals, what we want is we want to know if we took you guys and let's say we're looking at the population of Preble County High School students, and we want to know if we take just a certain sample, what's our confidence that it falls within that certain range. And we're going to have different intervals that we're, different percentages that we're going to talk about, but all this confidence interval is going to do is we're going to say, okay, 130, that was our X bar, that's our sample average, that's your guys' average. We want to know what this range is that we're pretty sure. We don't think that everybody in Preble County has an IQ of that 130 average. And it's not very likely that the average IQ is going to come out to be exactly 130. But we want to know an interval that we're pretty sure that everything falls in between. This is called our margin of error from here to here. Actually, this number right here and this number. What we're going to do to get those numbers is here we're going to take the 130 minus your margin of error, and that gives you the low end of the interval. And over here, guess what you do on the other side?
You do the same thing.
So that's going to give us our confidence interval. All right? And there's going to be a certain level of confidence that we're at. And the ones that we're going to deal with the most, and I'm going to give you a chart that shows you that, The ones that we're gonna deal with the most are 90%, 95%, and 99%. That doesn't,
Do you get E by dividing?
I'll show you how to find E. Alright, there's a formula to find E. Now, what this is doing, remember last chapter we talked about, you can't always deal with the whole population, you can't find the whole population, or, survey the whole population, or get every set of numbers for the whole population. So, and a lot of times we won't know the information about the population. So we won't know the standard deviation, we won't know the mean of the population. Last chapter they told us those things every time. This time they're not going to. We're saying, if we just take your sample, what's the probability that everything's actually going to fall in that interval, in that range? All right. So with these statistical inferences, and I'm going to go through a bunch of just sort of real quickly. Same as last chapter, we make an inference. Our n needs to be greater than or equal to 30. It's got to be normally distributed, and we'll know the standard deviation. They'll tell us the standard deviation just to make it a little easier on us here at first. Remember a parameter? Does anybody remember back from way at the start of the year? Parameter always goes with a what? Population. A statistic goes with sample. All right, so we got sample statistic, and we're trying to see the population parameter. So sort of what we're doing here is we're saying, if I took all your IQs, like I was explaining there a second ago, if I took all your IQs and it come out to be an average of 130, how close are we, or what can we expect from the entire population of Preble County? Alright, so that's what we're trying to see here. Point of estimate, that's what we're doing, we're sort of estimating. We're saying, your sample, our sample for in here is 130, that's our point of estimate. We're estimating that the average of the whole population would be about 130. So point of estimate is just a single value estimate for a population parameter. The most unbiased point of estimate of the population is the mean. And remember, for our sample, mean is always going to be the X bar. Mu, we're not going to know mu this time. Last chapter, again, they were telling us mu every time for the whole population. This time we don't know that. Validity of estimate is increased if the sample statistic is unbiased. That's always the case. If anything's biased, that means something's wrong. So if I took a classroom of the AP Calc class and tried to compare their IQs to my sophomore geometry class, it's not really, it'd sort of be biased because there's probably going to be higher than the average. Sample statistics has a low variability. The bigger our n is. Remember, n is how many items you have in your sample. So the bigger n gets, the better off your statistic is going to be. Social networking, just to go back through this real quick, this is something you should be able to do. The following represents a random sample of friends for 40 users. Find a point of estimate for the population mean, and all they're saying when they say all that, point of estimate for the population mean, is they want you to find X bar. How do we find X bar for a set like this? What do you do? How do you find X bar? What is X bar?
You add all the top row together and divide it by the number of the.
Not just the top row. You add all of them up, divide it by how many of them there are. Remember, some of these, because as the chapter goes along, what we can do on here is hit stats, edit, and you put them in the list. And then the list will do all the stuff for you, right? It'll find all the stuff for you. The bad thing with making a list, if we're 30 or more, putting 30 numbers in one of those lists, not as easy, right? When we get to the small ones next week, when we get to the small sample sizes, then it's not as bad. You probably want to put them into the list. So that's all we're going to do is we're going to take all these, add them all up. You could just put them in your list on there and it'll do all of it for you. Divide by how many of them there are. Here it says there's 40 users, so we're going to add all these up, divide by 40. I added all those up. Remember this? What's this symbol mean again? Sum. So sum of all the x's, 5,232 divided by 40, that's going to give us our x bar. I guess I thought I had the answer up here. So 5232 divided by 40. 5232 divided by 40 gives me 130.8. Usually I take somebody like Sean here and I make fun of him because this is talking about social networking on a website. And if we look down through here, this is mine right here. It tells how many friends I have.
I'm the one to the left.
And then we look here, that's Jesse.
I'm the one in the middle of that.
That's Jesse right there, that 51. Those are probably his mom, his dad, his grandma and grandpa.
Yeah, my family, that's about it. You're right.
Alright, so what we're saying with this, when we get this 130.8, that the average person has about 100, and we might want to round this off since it's talking about people, has about an average of 131 friends. Market researcher, we do the same thing here. Find the point of estimate, we just add all these up. Divide by how many of them there were. There were 50 of them, 12.4. Your point of estimate, so you're saying, if we're looking at a number line here, 12.4 is going to go right in the middle. That's going to be your X bar. And we're going to talk about how to make that confidence interval. So that's our point of estimate. Jumped ahead on me. That's our point of estimate. The probability that the population mean is exactly 12.4 is very, very unlikely. It's not very likely that when we come up with that sample mean, that your population mean is going to be that exact thing. All right? It's almost 0% chance that it's going to come out to be exactly that. But we can make an interval estimate and say, okay, we don't think it's exactly 12.4, but we do think it's going to fall within a certain range here. So this is our interval estimate. And again, from here to here, that distance is E. Here to here, that distance is E. You're going to find this low number down here by subtracting E from the your point of estimate. Find the upper one by adding E to it. The other thing I want to say while we're looking at this, if I gave you, say we did this, and let's make something easy, we'll call that 10, come down here to, we'll say 8, 12, what would E equal? 2. Right? So you can find E, if they give you the confidence interval, you can find E by subtracting the median, or not the median, the mean here, minus one of the ends, and that's going to give you E. They could give you, let's say they just gave you this. Told you this was 100, this was 200, and they want you to find the mean there, 150. All right, add them up, divide by 2. So you can find all that stuff, and I know some of the assignment that you had, that was a lot of it, was just messing around with that interval. Sometimes they'll tell you, maybe they tell you that the mean is, the X bar is 20, and they tell you E is 7. What would this end of the confidence interval be? 13, this end, 27. So that's all stuff you can do if you know 1 or 2 parts of it as we go through this. How confident do you want to be? To form an interval estimate, point estimate goes in the middle, add, subtract the margin of error. We just talked about that. Before finding the margin of error, so before we find that E, we got to know how confident we want to be. The ones that we're going to use the most are those 3 right there, 90, 95, and 99%. This next slide, I think, is something you probably want to make sure you write down because we're going to use it this whole chapter. This right here, very, very important. Level of confidence. So if you don't write down anything else today, I'd write down that because you're going to have to find these Z-scores. And instead of finding these Z-scores over and over and over again, probably a good idea to have this. Right, Grant?
On one of the homework problems, I think it said to use like an 80%
Right, and we're going to have to talk about that.
Yeah.
So maybe even, let's even do this. Because there was quite a few of them that say 80%. Let's put 80% as part of this chart, and we'll just figure it up right now, and you can have it on there to refer back to all the time. What you do on this? This is just like we were doing last chapter. And the fact that we're looking at a curve, I'm going to try to draw this curve so that I don't affect everything else. We're looking at our curve, and what we're saying is we want to be in a certain range. So we want to be in some certain thing from here to here. And we want a level of confidence that our mu is going to fall in that range. So if it's 90%, what they're saying is that these Z-scores right here, this Z-score and this Z-score, at 90% would be 1.645 on this end, and on the other end it'd be a negative 1.645. So we're at those Z-scores, that's what this is saying. 99% confident, notice we're out at 2.575 Z-scores. So we're out there pretty far. Almost everything, remember everything, it's unusual if it's outside of 2 Z-score, positive or negative. So 2.575, almost 2.6, that's pretty far out there. It's going to be very unlikely that anything falls out there. So what we want to do to find this, to find these Z-scores, if it's not one of these 3 that we sort of just use all the time, what we have to do is we have to find these 2 areas right here. And then we're just going to use our calculator. And on our calculator, last chapter all we did was we punched in, we hit second, bars. This was on that last test. And we go to inverse norm. So you go second, bars, then you do the inverse norm, and then all we have to put in is the area, and that's going to tell us our Z-score. Well, we want, if we're doing 80%, we want 80% of the stuff to fall in here. Alright, so we want 80% to be in there. Well, what percentage does that leave to be outside? 20%, right? So we want 20% on these two tails, but our calculator can only do one tail at a time. So what percentage is going to be out here? 10%. So what we're going to do is we're going to hit second bars, inverse norm, and then we're going to put in 0.10. That's 10%. And the calculator's already got in, whichever calculator, whether you have the new one or the old one, it's already got mu is 0 and your standard deviation is 1, as long as you haven't changed anything. And then you hit equals, and it comes up to negative 1.28. Well, we don't really want the negative, we just want the positive. So for 80%, it's going to be 1.28. That's your z-score every time if you're at 80%. And we could do others, you know, we could do 75%. 75% out here, instead of having 20%, we'd have 25%, and you just take half of that, and that's going to give you this, and you punch that into your calculator. So you use that inverse norm, which is the area. If we did 75%, that's 0.25, take half of 0.25, and you get 0.125. So if we hit second bars, inverse norm, 0.125, paste, enter, and we end up with 1.15. So 75% confidence interval would have z-scores. What you're saying there is you're saying, I'm going from z-score negative 1.15 to 1.15. That's the area we're looking at. Probably that make any sense. And we could, so on all those, same as last chapter, you use that inverse norm because you know the area and you're trying to figure out, okay, where am I at? And notice, as my confidence interval, as I went down to 75, the spread got closer and closer together because you're less confident that it's going to fall in that range. The values that separate the sample statistics, just going back over this again, remember if we're outside 2 standard deviations, or z-score of 2 or negative 2, if we're outside that, it's improbable that it's going to happen. Stuff that's in here is more probable. Level of confidence, see the probability that the interval estimate contains population parameter. So if we're looking at this, these are our level of confidence from negative z to z. The remaining area is 1 minus that. That's what we were just doing. This out here is 1 minus whatever your level of confidence is. And then you got to take half of that to just get to one side so the calculator can understand it. Level of confidence is 90%, means 90% confident that the interval contains mu. So what we're saying as we're doing this, we're saying that as we find these samples like we were doing last chapter, as we find the sample mean, we're 90% confident that that population mean is going to fall in this range. All right? So we're not sure what the IQ of all students in Preble County are, but when we found yours and we said it was 130, and we find this range right here at a 90% confidence interval, then we're 90% sure that somewhere in there mu is gonna fall in that range. %, same idea. All right, sampling error. This is your E, and this is important too. So you can find your E. The difference between the point of estimate and the actual population parameter value. This is what your E is going to equal. That's your sample error. It's X bar minus mu. The problem with that is we're not usually going to know what mu is because we don't know what the population mean is. If we knew that, then we wouldn't have to go through all this. The X bar is going to vary from one sample to the next. If I sample you guys, then I take some other class and I sample them, the X bar is going to come out different. It's not going to be the same every time. So those two things change every time. Or well, actually one of them's unknown and the other one changes every time. So that sort of messes everything up. So that's why we're getting this interval, why we're saying we hope it falls in this range, or we think it's going to fall in this range. The margin of error, this is the formula for margin of error. You need to make sure you have that down. So E is called the margin of error. I think it's also called about 6 other things. It's also called the maximum error of estimate and error tolerance. I'll probably call it margin of error every time. The one we're going to use this right here is the main part of the formula. That's your E. Your Z-score for your confidence interval times your sigma, your standard deviation, divided by the square root of n, which is the number in your sample. Probably want to write down here for your sigma. You're not usually going to know what sigma is because we don't have the population information. So what we're usually going to put in place of that is S, the sample standard deviation. So you're usually going to put the sample standard deviation in place of that sigma there. So this is just to find E. This is to find, we figure out, we can add them all up and divide by how many of them there are and come up with the fact that our mean, or our X bar is 20. And then we're going to figure out our parts out here, our interval, by finding this. Here we subtract it to get the low end, we add it to get the high end. The magazine advertisement data, 95% confidence to find the margin of error for the mean number of sentences in all magazine advertisements. Assume that sample standard deviation. So here they're telling us that the sample standard deviation, that's our S, is 5.0. We want to find the E. So for our 95%, it's this. Instead of doing all this, you can look at that chart. Somebody help me out. For 95%, what was your Z-scores? 1.96. So that's 1.96. What's this one over here? Negative 1.96. All right, that's the first thing they're doing. They're actually figuring it out longhand instead of using the chart or calculator. They put them in there. So we're trying to find that confidence interval. We can approximate the distribution of sample means, normal curves, by using that central limit theorem that we talked about last chapter. We because our n is greater than or equal to 30. Forget this is here. All we're going to do, we're going to plug in 1.96. They told us what was S, 5.0, I think. N was, what'd they say this time? How many people did we have? 40? Can't remember. Come on. 95%. I think it was 40. Let's see here, it's on that was 50. Put in 50 right there. When you do this formula for E on your calculator, the easiest way to do it, take your Z-score, and it's just the positive Z-score. It doesn't really matter if it's the positive or the negative, but just use the positive. So the positive Z-score times your standard deviation, hit equals, and then divide by the square root of whatever your N is. Don't make it harder than it is. Can you handle that, Grant? Too busy messing with that pointer. Alright, just want to make sure. So what we're saying here, 1.4 is our E, or approximately 1.4. So if we're going to create, and this is the part you have to be able to do, we're going to create a confidence interval here, several different ways you can write it. We know that our trying to think here, did we, somewhere we already did this problem, I don't remember what it was. We are, do what? So when we're looking at this, we should already know what this X bar is. It was on a problem earlier. I don't remember what it was. But all you're going to do to find this low end, let's take that X bar minus 1.4. That's going to give you that end of the confidence interval. And take this X bar plus 1.4 and it's going to give you this end. This is one way to show it. As a graph is one way to show it. And there's several other ways to show it. So if we had this is the one, so this is social networking. What was it, 1.38 or 130.8? We found our E is 16.4. When I went through and did all this at a 95% confidence interval. So if we're looking at this, when we go to draw this graph, 130.8 goes here. We subtract 16.4. That gives us what, 114.4 on that end. On the other end, we add 16.4. That sounds right. About 147.2. All right, so that's our confidence interval. Other ways to write that, and what your calculator is going to show you, and I'm going to show you how you can just get it on the calculator here in just a second. The calculator is going to show you this. 114.4, comma, 147.2. Now the bad thing with that is, it shows you that confidence interval, but does it tell you what the mean is? No. How could you find the mean if the calculator gives you this? Add them both together and divide by 2. And that's going to tell you what the X bar, the mean was. So again, this right here, what we're saying when we're looking at this confidence interval is that the population mean should be within those two end points. This might not be a bad thing to write down these steps. Constructing confidence intervals to make these confidence intervals, number one, find the sample statistic N and the X bar, and you gotta find the X bar. Number two, specify sigma if it's known, otherwise, otherwise you can just use S. You can find S by what that formula right there says. I would highly suggest that you guys are writing this down, not mess around talking. On this, instead of using this formula, because that's sort of a long formula, instead of using it, you can put in the list on the calculator. If you're given some kind of list, you can put that list in on the calculator, and it'll tell you what S is, it'll tell you what the standard deviation is. To use this, that's where we need, remember those big long charts that we were making, and we had X, then X minus, or mu minus X, and so on and so on. That's what we'd have to do there. It's a whole lot easier just to use the calculator. Notice this also says if your sample size is greater than 30. We're going to talk about if it's less than 30 next section. So those first two things, you find your N, you find your X bar. If you punch all this into the list, it'll tell you what X bar is. It'll also tell you what S is. Next thing you do, third thing, find your critical values, your Z sub C here. Those are your confidence intervals. It's going to tell you that normally that level of confidence, that confidence interval, it's normally going to be 90, 95, or 99. You got to change those into the Z scores that's on that chart.
I didn't get the last one.
That
Yeah, let me get that.
I have to move you right back up front. Do what? I believe you. But you're annoying. Focus.
I got a good grade on my last test. What did I get, a 95?
Are you writing or talking? No, you're not.
I got it.
You're great.
Huh?
You're great.
It's funny or bad?
Yeah, I guess that's not funny at all. Funny like a heart attack. Alright, so find the critical values. Again, use that chart. You gotta know those numbers that's on that chart. So keep that chart handy. Seems like I can pass out another chart here that's gonna have it on it here pretty soon. So keep that chart handy. Know that for 90%, what's the Z score that corresponds to 90%?
1.649.
Alright, and then and be able to use all those. Those are the ones that you're gonna have to use them over and over and over again. Be able to find E by using this formula. Your z-score times your sigma divided by the square root of n. Remember that sigma there could also be s. N is the sample size. And then the last thing, take your x bar minus e. That gives your low limit. X bar plus e, that gives your high limit. And what we're saying is that with a whatever percentage confidence, we're confident that the z, or that your mu is going to fall, the mu for the whole population is going to fall within that range. Sleep like it. Mr. Wendell was in here.
Not me.
Her.
Not me.
Yeah, I have a feeling that I have a feeling Mr. Wendell and Jacob don't get along too well.
No.
Wendell gets mad at falls asleep.
Wendell gets mad at me.
Remember Carson falling asleep? He goes, Spiller, you didn't wake up.
He just-
Better just act like you're asleep and not listen to him. Act like you're passed out.
Still cold. I'll do that next time.
So this is another way.
And then just.
This is another way you could represent it. The calculator represents it one way. You can show it on a graph, showing it graphically. You could show it this way using the less than symbols. Another way, these are all the ways that it could be shown. You could show it by the graph like this. Could be shown this way. Could be shown this way. It could be shown with the X bar plus or minus 1.4. All those work the same. This is the one that we'll probably use the most to show it because that's what the calculator shows you. And I'm getting ready to show you how to do it on the calculator here in a second. So that'll be probably the one we use the most. When we're interpreting this, you gotta be careful, and I say it wrong all the time. We know that the population mean is a fixed number. That population mean is what it is. We may never know exactly what it is, but it's always right there, and it's always that same thing.
It's a fixed number, but it's constantly changing.
No, the population means not constantly changing.
Population's constantly changing.
Well, if your population changes, then you have a different mean. So, because you don't have the same population, all right? So if we have the population of cows in the world right now, and we want to find their average weight, that's a set number. That number is never ever going to change for February 2nd or February 10th, 2017 at 8:19. That number is never going to change.
It's the last thing.
All right. So, wish you paid as much attention, Dalton. It's incorrect, and this is what I say all the time. There's a 95% or there's a 90% probability that the actual mean is in that interval. That's not actually the case. What's actually the case is if we keep doing sample sizes of that same size that we already did, there's a 90% chance, or 90% of the time, the mean is going to fall in those intervals. If you say it this way, I won't get upset because I think it's all right also. So if a large number of samples, 90% chance that mean's going to fall, or that mean the actual population mean's going to fall within 90% of those. You ever seen something like this on a, let's say you took a test, and you ever, like the ASVAB or something, and you see your test scores look like this? This is what they're saying. Notice here how this mu bar right here goes up through there. See how it hits that one, it hits that one, doesn't hit that one, hits 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 all but one of those. That's what we're saying when we're saying this, is that 90% of the time, the mu is going to fall within that interval that we got. Notice that we had this one right here where the mu didn't hit the interval. All right, this is the calculator. So write this down. This is how you do it on the calculator. How you find a confidence interval. Again, the bad thing with the calculator is it doesn't show it to you, it doesn't quite explain it as well. And this is something new, all right? So this is not the same as some of the other stuff. Don't forget about the inverse norm, to find the area and all that stuff that we were talking about a few minutes ago. Do what? Oh, right. You don't have that.
It's impossible.
How do we read stats test? Is that your stats, YouTube? Standard deviation.
Did you record this or something? Is this on move?
A little bit.
How does it build Not very fast.
Grant got in your computer and looked at all the PowerPoints.
That's right. No, because I'm not listening.
It's kind of funny. You'll
No.
actually chuckle about it.
No.
I found Porky again.
Huh?
I found Porky again. Cairo, Egypt.
So using calculator to find the confidence interval. On your calculator, I think the new calculator and the old calculator, they're exactly the same on this. So this isn't different whether you have the old calculator or the new calculator. Let me clear off mine. Go to stat, go over to test. So on stat, we've been on edit, we've been on calculate, now we're going to test. You go down to the Z interval, which is number 7. Go down to the Z interval, hit enter, and it pops up this second screen. I think both new and old calculators pop up the same screen. What you're going to do right here, and this is important, you might want to put something there where it says, because it says data or stats, data. Here it says data or stats. Where it says data, that's if you're using one of the lists. So if you put all your numbers into a list on the calculator, then you want to highlight data and going down from there. If you didn't put numbers into the list, if you just know like the X bar and you know the standard deviation and you know the N, then you want to highlight stats. So on most of the problems, I think most of the problems on the homework this time, you'll want to be on stats. I say hit enter here. You don't really have to hit enter, you could just scroll down, right? So you go down through there, you put all that stuff in, your sea level. Again, most of the time it's going to be 0.90, 0.95 or 0.99. You go down to calculate, hit calculate, and it shows you this screen. On the screen, it'll say Z interval. And then it gives you the interval. This is your answer. Then it also tells you what X bar is, and it tells you what N was. I don't know why I wrote 23 there, that's just what my calculator said. That's not always going to be the case. So if we took this one, and we knew our standard deviation was 53.0, our N is 40, plugged it into, and we found the X bar was 130.8, we did that earlier, and we want confidence level of 99%. We punch all that stuff into the calculator. Thought it was gonna do it. We punch all that stuff into the calculator, so if I hit stat, go over to test, down to Z interval. This time we're going to put in stats because we know the statistics here. We're going to punch in 53.0 and we're going to punch in, and these are always out of order. I don't know why the calculator and the book don't line up better, but you have to just look. 130.8, and then our N is 40. Our confidence level this time is 0.99. Punch all that in, and of course I messed up. Hit the button too many times, don't hit enter too many times, and it comes out to be 109.2 to 152.4. So with this, back to that original problem that we did way back at the start, what we're saying is we're suspecting that the average person that's on that website, whatever it was, one of the, I don't get on websites, so what are the websites where you, what's the popular websites?
Google.
No, like the ones you go to talk to people.
Facebook.
Facebook, something like that.
Oh,
So
MySpace.
you go on MySpace, Facebook, I don't know, whatever they are.
MySpace.
MySpace, isn't that, that's an old one, isn't it?
Yeah, that's pretty good.
Is it? I wish Dalton listened as half as well when he's trying to make a joke. So maybe he would say, this is where I need to be able to hit pause, so I can make that comment about the last test. So we're saying that the average person that's on that website has between 109 and 152 friends. Or we're guessing that that's about the range. We don't know for sure where that mean person is, but they should be within that range somewhere. This is all just doing it out longhand. We find E, subtract it all from each side. You should still be able to find E and stuff. Alright, last part here. The higher the level of confidence, the wider the confidence interval. So what we're looking at here, even though it seems like 99% confidence interval would be better, all that 99% confidence level is telling us is that we're making our interval wider, so we're more confident that it's going to fall in that range. So just because we're saying with a 99% confidence, that doesn't mean that's always better. All right? So the higher the confidence, or the higher the confidence level that we want, the wider the interval. To make stuff better, what we normally would do, not make the confidence, not make the percentage higher, but make our sample size bigger. The bigger our sample size, the more confident we can be that we're getting closer and closer to what the actual mean of the population would be. This is what you do need to write this down. Very important to estimate the sample size. To estimate the sample size. This formula is very, very important. If we're looking at, so you're getting ready to do a study, and you want to know, Jesse wants to be writing this down, instead of sitting there looking, because then he's going to be mad when I go on. I know. When you're looking at something and you're saying, okay, I want to make up this study about National Trail. And we want to know how many people do we actually need to survey to get a good grasp on what should happen. The way we can find that is by using this formula. That's going to tell us how big of a sample size we actually need to get a good estimate. Again, on this, your Z, C is your confidence interval, so that's going to, or your confidence level, that's going to be like 90%, 80%, but you got to change it to the Z score. Your E is your margin of error. Your sigma is your standard deviation. You multiply your Z score times your sigma. Remember, sigma could be S also. Divide that by E, which is your margin of error. You square that answer, and that's going to tell you how many people you need to survey, or how many people you need, or how many scores you need in your sample. When you get this, it's going to give you some number, like let's say it gives you 110.3. Well, what we want to do with that is we always want to round that up. We talked about this earlier this year. One of the other things that we did earlier this year, we always rounded up. Same thing here. So if this is telling us that N should be 110.3, then how many people do we actually want to survey? 111. We want to round it up. All right? And that's going to tell us the smallest sample we could use to give us a good estimate of the population mean. It's about 111. So using that formula. If your sigma is known, or if your sigma is unknown, then you can use S. We already talked about that. As long as your sample size has to be bigger than 30. This is all the same stuff. This is finding it out longhand. I don't want to do most of it longhand. If we take this and we want to find the sample size, then we know N is going to equal 1.96 times 1.96 times our S, which is 5.0, divided by our E, which is 1. We're going to square all that. I'm sure it did all that for us. 96.04. That's our N. So that means we want about 97 people. Rounded to the next whole number, 97. So you should do at least 97. If we do 100, is that gonna be bad? No, it'd probably be better to do 100 because it's a nice even number and we could maybe make our calculations a little better. All this one did was just doing the same thing for 3 different numbers. Should have most of this. Now, again, what Jesse tell me he's gonna do,
Not each Slater.
not use the Slater one, right? Go back and try him again. I mean, when I come around and check it next week, are you still gonna get credit for it if you got Slaters written down?
Yeah.
But I'm hoping that most of you are seeing.
I literally had no clue what to do, so I had to come up with something.
So now I'm hoping you have some idea, right?
Yeah.
As a matter of fact, if some of you actually did some of it, you want me to go through a few of them? I will. That's up to you guys. Want me to go through a few? Huh?
Yeah.
So get your books out. We'll go through a couple problems. I'll do them up here. Let's do some of the early ones first, because you guys just, I'm not gonna do them if we're just gonna start at the hard ones. Because,
We got up to 46.
yeah, but I don't think that you guys, actually did the problems on a lot of them. So that's what I'm saying is, don't put it in your pocket.
Oh, that didn't last long, did it?
No. Looks like you got yourself a new laser.
Is it locked?
Good one.
Swear I thought I was teaching high school. Give me a problem. Which one?
Go ahead.
Right at the beginning, where ones you want to see actually work, not by Slater, by Mr. Ebersol. I'll do 29. Blank slide here. You want me to do 29 then? 29, find me some of the other ones that you want to see. Determine the minimum sample size N needed to estimate mu for the given values C, S, and E. So in 29, they give us C is 0.90. S is 6.8. Remember, S is your standard deviation.
It gives you X bar.
And E is 1. We want to know, we want to have a 90% confidence interval. Our standard deviation 6.8. Our margin of error is 1. what's the smallest sample size that we could use here? So we're using that last formula. N equals, what was that last formula? N equals what?
Z-score, standard deviation,
ZC times standard deviation.
divided by E
Square.
divided by 2.
And all we're gonna do is plug in here. Now our Z-score, Z of our confidence interval. Do we just put 90 in there?
Yeah.
Could you put the
We gotta put the Z-score in. You gotta look at the chart. 1.645, everybody agree with that?
Yeah.
So you put that in for your Z-score, don't use the C, that's your 90%, that's the confidence level you want, you need the Z-score, so 1.645 times, what do we put in for sigma? That's our S, alright, even though this is sigma and this is S, we just replace sigma with the S, 6.8, divided by our E, which is 1, squared. Somebody help me out with the calculator, what's that give us? It's not what Slater told you, is it? 125 point what?
1.6.
Now, the thing with that, is that the answer we want? What's N stand for again? Number of items we're taking, right? Do we want 125.126 items? No, we want to round it. So what's our answer gonna be? 126. So about 126 items, at least 126 items.
Slater got the same. But all I got was, all it said was 126, so I had.
Did 33.
33. 33. Find me some before these 1 through 28. I'll do a couple of those.
12.
After I do 33.
Yeah.
33. 33 says, use the given confidence interval to find the estimated margin of error, then find the sample mean. A government agency reports a confidence interval of 26.2 to 30.1 when estimating the mean commute time in minutes for the population of workers in a city. So it says 26.2 to 30.1. That's our confidence interval. All right, again, you could write it like this. This number here is going to be 26.2. This number's 30.1. We want to know, what's this number right here? That's the mean.
28.15.
And then we also want to know, what's the E? So we want the X bar. How are we going to find the X bar?
Add those up and divide.
Add those up, divide by 2. Somebody, what's it come out to be when you add them up, divide by 2? 26.2 plus 28.15. So that's your X bar. Now you also want to find E. How can we find E?
28 minus 26.2.
All right, you could take this minus that. The other thing you could do is instead of adding these two together and dividing by 2, guess what else you could do?
Times.
Instead of adding here, minus. So we could do 30.1 minus 26.2 and divide by 2. What's that give you? So that's your E, that's your margin of error, that's your X bar, your mean. Next question. Stuff's not,
It's easy.
yeah, it's not near as hard as what the book sort of makes it out to be. Number 12, I think number 12 is the same idea. Use the values on the number line to find the sampling error. Actually, this time they just want you to find the error. So on number 12, they give us a number line. And I'm not going to draw the number line. They tell us X bar equals
46.56.
46.56. And they tell us mu is 48.12. Normally, we will not know what mu is, but if we do know what mu is, we had a formula at the very beginning that said all you got to do with these two to find the error is subtract them. What do you get when you subtract those two?
You get 1.56.
Everybody agree with that? Negative 1.56.
Yeah.
So that's your margin of error. How far are we off? Our sample, we said that the average in the sample was about 46.56. All you do is subtract them. Normally though, I don't even like this problem because normally you don't know what the mu is. You don't know what the population mean is, so there's no way to find it that way. You gotta use the longer formula. Other questions? Which one? 6. 6. Construct the confidence interval at the given level of confidence.
Oh, never mind, don't do 6.
Don't do 6?
Yeah.
I
Do,
know.
47.
I'm already looking at it, so. We got 0.85. When we're doing this, remember we're looking at this, we want 85% to be in here. That leaves us with 15% on the outsides, but we don't want the whole 15% to find this number. We just want half of it, so somebody help me out. 15% is 0.15, somebody tell me what half of 0.15 is. Of 0.15. Now what we want to do is we want to hit inverse norm on the calculator. Inverse norm. And all we're going to punch in is the area, which you say it was 0.075. Put that in, and it should tell you this Z-score right here. Anybody helping me out? Inverse norm, 0.075. 1.44. Now is this one 1.44?
It would be negative.
That's negative. What's this one? 1.44. And our confidence interval would just be that. Everybody get that full assignment written down?
Yes, sir.